We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
I, Divyang Patel, working as an assistant professor in Electronics and Communication Engineering Department, SHANKERSINH VAGHELA BAPU Institute of Technology, BAPU Gujarat Knowledge Village Campus, Gandhinagar. Today, I conduct the lecture of the subject Digital Electronics and Digital Instrumentation. Subject code is 3340904. So topic to be covered in this lecture is the combinational circuits. In that, the half adder, full adder, half subtractor and full subtractor. So let's start with the first half subtractor. What is half subtractor? Combinational circuit which adds to 1-bit binary number is called the half adder. So now let's see the truth table, their logic expressions and the logic diagrams of the half adder. So truth table consists the combinations of the inputs and the output. There are 2 inputs A and B and the 2 outputs sum and carry. Due to the 2 inputs there are 4 possible combinations are there. So here first combination is 0 0, then 0 1, 1 0 and 1 1. So for all the 4 combinations there are 4 outputs sum, 4 outputs carry. So what is sum and carry for the first combination 0 0? So if we add the 0 into the 0, then the sum will be 0 and the carry will be 0. If we add the 0 into 1, then the sum will be 1 and the carry is 0. If we add the 1 into 0, then sum will be 1 and the carry is 0. If we add the 1 into the 1, then its sum is 0 and the carry will be 1. Here the plus sign is for the OR, not the additions. So in the digital electronics, the plus signs here represent the OR operations. So here this is the truth table. Now let's see the logic expression for the sum. How to find out the logic expression for the sum? Here in the column of the sum, there are 2 ones are there. First combinations where the 0 1 is represent and the second combinations there are the 1 0 is there. So in that, based on these 2 ones, the expression for the sum is A dash B or A B dash. It represents the exclusive OR gate. A exclusive OR B, A XOR B. So this is the logic expression for the sum. Now logic expression for the carry, here in the column of carry, only single 1 is represented. In that, the combinations for the input for this one is A dot B. It means the A and B. So this is the expression for the carry. Now let's see the logic diagram for the half adder. So it includes the XOR gate and the AND gate. XOR gate is represent the sum operations and the AND gate represent the carry operations. So this is all about the half adder. In that we can add only the 2 bits. So to add the more number of bits, we have to use the full adder. So now let's see the full adder. In the full adder, 3 bits can be added at the same time. The third bit is a carry from the less significant column. So here let's see the truth table for this full adder. Here the 3 combinations, 3 inputs are there and the 2 output sum and the carry out. So for this 3 inputs, there are total 8 combinations are there. So for this all the 8 combinations, the sum and the carry is represented in the truth table. So let's see how this sum and carry out present. So here the A or B, just like the half adder, but the third bit C in is added in this full adder. So here in the first combination 0 or 0 or 0, here 3 bits added and the result is 0 and the carry out is also 0. Now let's take the another combinations. In that the A is 0, B is 1 and C in is 1. So in that case 0 or 1 or 1. So first we add the 0 and 1. It shows the output as 1. In that 1 we another add the 1 so that the 1 or 1 is equal to 0. So here the 1 or 1 is 0, but it represents the carry out. So carry out is 1. So in that case the sum is 0 and the carry out is 1. Same way we can find out the sum and carry for all the other combinations. So now let's find out the logic expression for the sum. So here in that case we check the column of the sum in the truth table. So based on the column there are 4 ones are there. So for that 4 ones we write down the logic expression for the sum. Here the first one combination is A dash B dash C in or A dash B C in dash. The third combination is A B dash C dash in, and the fourth and last combination is A B and C in. So here from this first expressions, in the first two terms, in the first second and third term we get the common C in dash, and the first and the last term we get the common C in. So now here in the first term and the second term we here the first term the A B dash or A dash B, it is represent the XOR gate, and in the second term, this second row second term, the AB or A dash B dash is represent the XNOR gate. So it is the combination of it is the complement of the XOR gate. So here the A XOR B dot C in dash or A XOR B dash into C in. So here this third row represent the XORing between the A, B and C in. So here this is the expression for the sum. Now let's find out the expression for the C out. Here the C out, there are total 4 number of ones are there. So write down the 4 input combinations for this 4 ones. So here already written in the screen. So now let's simplify these equations. In that simplifications, here for the first in the first row first and second term C in is common, and the last two terms AB is the common, and in the bracket C in dash and C in. So this is gone because due to the Boolean algebra's laws. So here this is the expression for the C out. So now let's see the full logic diagram for the full adder. So here the sum expression is A XOR B XOR C, and the C out is AB or A XOR B into C in. So now let's see the diagram of the full adder. So here first XOR gate, second XOR gate. The first XOR gate gives the output of the sum of the A and B. Then second XOR gate gives the output of the A, B and C in. So it means the total sum. Now the carry, 2 carries from the first AB sum, we get the carry. The another XOR, another AND gate gives the another carry. Now we add those 2 carries, it gives the final C out. So here this is the logic diagram of the full adder. By looking at this diagram we can find out that by combining the two half adder, we can get the diagram of the full adder. So here, let's see. So this is the first half adder and this one is the second half adder. By using this two half adder, we can construct the one full adder. So full adder is a 3-bit additions. So this is all about the full adder. So now let's take the another topic, that is the half subtractor. It means the difference between the two bits. It produces the difference as well as the borrow. So truth, let's see the truth table for this. Here it has also have the two inputs A and B and the two outputs difference and borrow. So here the two inputs A and B having the 4 combinations, and it has the two outputs, one is the difference and the one is the borrow. So here find out the logical expressions for the difference, that is the here in the column of the difference there are 2 ones are there. So for these 2 ones, the 2 terms are there, that is the A dash B plus A B dash. It's like the A XOR B, and the borrow only the single one is there. So for that one, the term is A dash B. So let's see the logic diagram for this. Logic diagram for the half subtractor. So here first for the difference, it has the XOR gate, and for the carry borrow, it has the AND gate, but the one input is complemented. So we use the NOT gate to complement the input A. So in the input of the AND gate is A dash B. So that this is the logic diagram of the half subtractor. Now the full subtractor is a combinational circuit with the 3 inputs A, B and B in. So it is the subtraction between the A, B and B in. So now let's see the truth table. Here the 3 inputs, so total 8 combinations of this of the inputs, and the 2 outputs, that is the difference and the borrow out. Here the B third input is the B in, so that for the borrow we can represent by using the B out. So now let's find out the logic expressions for the difference. So in the column of the difference, there are total 4 ones are there. So write down the 4 terms for the all the ones. So first one represent the first term, that is the A dash B dash B in. Second one that represent the second term of the difference, that is the A dash B B in dash. The third one represent the term A B dash B in dash, and the last one represent the term A B and B in. So by simplifying this term, we can get the A B dash or A dash B into B in dash, or AB or A dash B dash ending with the B in. So by simplifying this, we can find out the relation between the A, B and B in. So here the difference is also same like the sum, the A XORing B XORing B in. Now let's find out the equations, logical expressions for the borrow out. So in the borrow out column, there are 4 ones. So all 4 ones, write down the combinations, write down the terms. So for the first one, the term is A dash B dash B in. Second one, the term is A dash B B in dash. The third one, the term is A dash B B in. And the last one is A B B in. By simplifying this Boolean equations, we get the A dash B B in plus B in dash plus AB plus A dash B dash into B in. So here let's taking out the common terms only. So now further simplifying this second row, here in the second row, the first term B in plus B in dash, it's equal to 1. So only that first term converted into the A dash B plus second term, here the XNOR gate is there, AB plus A dash B dash, or it's also known as the complement of the XOR gate. So here written as a complement of the XOR gate. So A XOR B complement into B in. So now let's see the diagram of the full subtractor. So here these are the equations for the difference and the borrow out. So for the diagram of the full subtractor, first let's A and B XOR, then A and B XORing with the B in. It means it gives the final output the difference A XOR B XOR B in. Now for the borrow, here we can add the two borrows from the two different XOR gate. So here for the borrow, the NOT gate, it means the complemented A is applied as an input for the first AND gate with the B input, and the second, the B in is applied with the output of the first XOR gate with complemented, and the both the two AND gates is added by using OR gate, which gives the final borrow output B out. So here also same like the full adder, that by using the two half subtractor we can construct the full subtractor. So here the first half subtractor, then second half subtractor. By combining these two half subtractor we can find out the full subtractor. So this is the circuits about the full subtractor. Thank you very much. This is all about the combinational circuits. In that we discussed only the half adder, full adder, half subtractor and full subtractor. Now in the next lecture we will discuss the more combinational circuit, multiplexer, demultiplexer and decoder. Thank you.